Hello my dear student, how are you? So, today I am going to start a topic that is electric motor. The question is, what is electric motor? An electric motor is a rotating device that converts electrical energy to mechanical energy. Right? Electric motor is used as an important component in electrical fans, refrigerator, mixer, washing machine, computer, MP3 players, etc. Do you know how an electric motor works? Let me explain you. In an electric motor, basically, or an electric motor consists of a rectangular coil ABCD of insulated copper wire. This is ABCD insulated copper wire. The coil is placed between the two poles of the magnet such that the arm AB and CD are perpendicular to the direction of magnetic field. You can see the direction of magnetic field from north to south here, this, okay, and AB and CD is what is perpendicular to the direction of magnetic field, right? The coil basically you can see, okay, here you can see. The end of the coil are connected to the two halves P and Q. This is split ring, half split ring P and Q, and this half split ring P and Q are connected to the end of the wire. The inner side of these halves are insulated. Yes, the inner side of this half. Let me show you the inner side of this half. Okay, the inner side of this half. Let me show you here. This is the inner side of the half. This is the inner side of the half. It is insulated and attached to an axle. The external conducting edge of P and Q. External conducting edge means what? This is the external conducting edge. Okay, this is what? This is the external conducting edge. Okay, the external conducting edge means this. The external conducting edge means this is connected. Okay, is the external conducting edge of P and Q touches to conducting stationary. Conducting what? Conducting stationary brushes X and Y. Conducting stationary brushes X and Y. These are the brushes X and Y. Right? These are what? These are the brushes. So I hope this point is little bit clear to you. Now, let me explain you the working principle. Right, let me explain you the working principle. The principle is what? There will be a force on current carrying conductor in a magnetic field. Right, on a current carrying conductor in a magnetic field. Okay, current carrying conductor on a magnetic field. My dear, initially this ABCD coil, okay, this ABCD coil is in the horizontal position. When you are going to close the key, the current is going to flow through the coil, okay, through coil ABCD. Okay, key is closed, the current flows in ABCD. As you can see in the figure, that BC and AD is parallel along the field. Therefore, no force acts on them. Okay, no force acts on them. Here, AB and CD will experiences the force, right? Here AB and CD will experiences the force, right? How AB and BC are going to experience the force? Basically, here the current is flowing. Let me draw. The current is flowing in AB in this direction, CD in this direction when you are going to close the key, right? Now, according to the Fleming's left-hand rule, okay, the force on AB will act in downward direction and the force on CD will act in upward direction. Let me explain you Fleming's left-hand rule, right? Let me explain you Fleming left-hand rule. My dear, this is a Fleming left-hand rule, right? Suppose that the current is flowing, this is A, okay, this is B, this is C and this is D. The current is flowing in this direction, okay, in this direction. Okay, now see. Now, this is your left hand. The middle finger shows the direction of current. The forefinger shows the direction of field. The thumb shows the direction of, the force. The direction of magnetic field. Basically, not a magnetic field. The direction of motion. Okay, where the magnetic force is going to act. Right now, place your okay, middle finger along the direction of current and place your forefinger along the direction of field, my dear, along the direction of field, okay, along the direction of field. Place your middle finger along the direction of current, forefinger along the direction of field, your thumb shows the magnetic force direction in downward direction. Are you getting my point? In downward direction on AB. Similarly, for CD, place your middle finger along the direction of what? Along the direction of current, your forefinger along the direction of field, your thumb shows the upward direction, okay, upward direction of the force, upward direction of the force. That is the Fleming left hand rule. Simple, very simple. Okay, now let me come to the point. Now here, my dear student, now here, AB experience, as I am telling that AB experiences a force in downward direction, right, and arm CD experiences an equal force in upward direction according to the Fleming's left hand rule. This causes the coil to rotate in anti-clockwise, right? The coil is going to be rotate in anti-clockwise direction, right? Anti-clockwise direction. When coil rotate in a vertical position, suppose it is rotating, when the coil rotate in a vertical position, this is a vertical position. When the coil is going to rotate in a vertical position, this is A, this is B, this is C, this is D. Okay, when it rotate in anti-clockwise, CD comes on the top, AB comes in the bottom, right? When the coil in the vertical direction, okay, when the coil in a vertical position, the brushes, that is X and Y, the brushes, that is X and Y, loses contact with the rings, that is P and Q, loses contact with the ring, that is P and Q, and current stops flowing, but coil does not stop. Due to inertia of motion. When coil rotates, rings also change their position and comes in a contact with opposite brushes. Yes, my dear, yes. Look here, when the coil rotate, then the split ring, the half of the split ring Q comes in contact X, and P comes in a contact with Y after half rotation. Please remember, after half rotation. Right, I'm going to repeat this statement again. When coil rotates, rings, that is split rings also changes their position and comes in contact with the opposite brushes, right, with the opposite brushes. The reverse, this reverse the direction when the Q comes in contact with X, when P comes in contact with Y. This reverses the direction of current through the coil, but the direction of current on right hand side or left hand side remains same. I mean the direction in this side, okay, initially here the direction in this side and the direction, okay, suppose this is my left hand, I am rotating, this is left and this is what? This is right, R-I-G-S-T, right, okay. So here in the left hand, initially the current is flowing in the left hand side in this direction, okay, initially the current is flowing in CD in this direction. After the half rotation, the flowing current in the left hand side remains same, the flowing current in the right hand side direction remains same, but the direction of flow of current in the arm changes, right, arm changes. So the force on right hand side is always in upward direction, and force on left hand side is always in the downward direction. And because of that, the coil continues to rotate in anti-clockwise, my dear, rotate in anti-clockwise. I hope you understand this topic. Thank you for watching this video.